Hello? Did we do it? I think we might have done it. I'm gonna make chat a bit smaller. Hello. I was accidentally muted. Let me arrange myself in such a way. Maybe we should put chat in the we can put chat in the over here. Maybe this is the way to do it. Maybe I haven't done a coding stream in a really long time. So I don't really have a good setup for it. I'll stand here. We can code while I'm standing here. Does that work? How we doing? How we doing, everyone? Hi! Hello! Hello, Astrolactopose. Hello, Hosato. Hello, Something Stochastic. Welcome, welcome, welcome. Happy to have you here. Happy to be back. Happy to be back. Not that I intentionally went on hiatus. I just didn't have the energy to organize streams for a bit there. So there's been a bit of a gap between now and when we last saw each other. But I'm back now. I'm back. Well, I don't know when I'm going to stream next, but so how have we been doing? How has everybody been doing? I hope that we've all been doing well in the intervening time. Been all right? Been doing all right? Hope so. I've been doing fine. I've just been busy. We're reaching that point of the semester, you know, and such is the way. Why did I put chat over here? I'm just gonna be looking over there the whole time. Nothing belongs on the second monitor. The second monitor is the mind killer. Everything goes on the first one. Oh, I'm glad to hear it. I'm really glad to hear that you've been doing well. This is great news. I hope that everybody is doing well. Oh man. Oh man. So, what are we doing today? Today, I know I said that like I was reading chat. I was not reading chat. That was just off the top of my head. No, what we're doing today is, so like way back in like February or something, we had that charity stream, right? Doing good, starting a week long. Oh, good. You deserve it. I know that you've been working really, really hard lately. So I'm really glad that you can get some good rest. You absolutely deserve it. This is fun. I'm gonna just, the chat can go right here. Oh no, though you actually do coding. People are gonna see my coding habits, and I'm a little nervous about that. But yeah. Oh, whoa, that was a bad choice. Anyway, okay. So what we're doing today? The thing that we are doing today. Back in February, we did that charity stream, right? And one of the rewards was I will analyze a set of data of chat's choice live on stream. And we, I don't think we really came to a consensus, but we kind of like all of us, including me, just decided we'd do some VTuber data. And this is a set of VTuber data, specifically like chat data that I found on Kaggle, which is a place that like has a whole bunch of data sets. They're not usually very well documented data sets, unfortunately. But yeah, this is a bunch of data about VTuber, like super chats and things like that. And it's mostly from like 2021, 2022, so it's pretty out of date. Like you're gonna see names on here that VTubers that graduated a long time ago. So sorry for that. But yeah, like this is around a little after the time when VTubing started getting really big in the English sphere. And that's the data we're working with today. I've loaded the data in ahead of time. There's technically I have 3 separate data files. This first one is information on the channels of the VTubers. So this is things like, here, let's look. You're gonna hear me typing a lot today. So we have the channel ID, we have the group that they're in. So we have Hololive, Hololive Indonesia, Hololive English, Holostars. We also have like a bunch of other stuff. We have the, oh no, this is name. Sorry, this is name. So this is the name of the YouTube channel, right? This is the official name of the YouTube channel. So this is Hololive's official channel. This is Hololive Indonesia's individual channel, and so on. And then like here's Tokino Sora, here's CyberLive, I guess. This is the English name of that. So like, for example, you can see here Tokino Sora is Sora channel, and then Tokino Sora channel in Japanese in like hiragana and then katakana. And then over here is like the There's the English name of the VTuber or the channel. Then we have the affiliation. So this is the group that they're associated with. Like the first 5 things in our data set are all Hololive. But then the 5th one is Aetheria, which I have never heard of. And then the group Cyberlive, we have the subscription count for that channel, and then the number of videos that have been published to that channel. And then the profile photo, which I don't really know if I'm going to do anything with that. We also have chat statistics, so let's see what we have there. This data set has the channel ID again, which is good. I use that to merge some of these data sets together. We have the period of time, so this is, it looks like it's cut by the month when these things were happening. The number of chat messages that were sent on that channel in that month, the number of chat messages that were sent by members on that channel in that month, the number of unique people that were, or unique accounts that were chatting on that channel in that month, the number of unique members, the number of bans on that channel in that month, and the number of chats that were deleted on the channel in that month. I think for the purpose of the stream, I'd like to stay away from things like bans and deleted chats, because that's just, that's not very fun or lighthearted. And then the last one that we have, the last data set that we have is, again, channel ID, so I can merge this stuff, period, so again, a month and year that this happened, the number of super chats that channel got, the number of unique super chatters, the total number, is this the, no, this can't be the total number of super chats. This must be the total value of all the super chats that that channel received. This is the average value of a super chat, maybe? I'm not sure what units these are in is the trouble. Maybe yen? I'm not sure. The total message length, so if you strung together, I'm presuming all of the words in the super chat messages, that all the super chat messages that were sent, the average message length. Oh, most frequent currency, so that's fun. I genuinely do not know what currency that this total super chat is. Or maybe this is the total number of super chats that were sent overall. This is not the most well-documented, or Kaggle I don't really trust to have well-documented data sets, but I have a link to the where I got the data set in the description, so I'm gonna actually pull that up so we can check. Let's see. We've also got most frequent, yeah, and most frequent color of the super chat. Let's see if we can find, let's see if this has documentation on specifically what is happening here. But yeah, 3 billion seems like a lot. Yes, that does seem like a lot. That's 3 million, right? Yeah, that should be 3 million, I think. Let me see. Super chat statistics, okay. Total amount of super chats in Japanese yen. Okay, it's specifically in yen. So this is, luckily this is actually well documented, which is unusual for data sets on Kaggle. So yeah, this is the total amount of super chats received in that period in Japanese yen. I wonder if R has any function to convert currency. R currency conversion function. That would be cool. Function to convert one currency. It's in Japanese yen. Yeah, it appears to be in Japanese yen. Let's see. People have created a function. Wait! Oh, that's a fun thing to do. But anyway, I merged this data in. So these two are two merged data sets where I merged channel data with this type of things. And I figured that we can go together, we can look through this data set together, we can do some analyses together. And I started us off, I was just curious, like the number of super chats per channel. So this first line of code that we have here aggregates the number, oh, this is the unique super chatters. So how many unique super chatters did each channel have overall? Which of course, this probably isn't the best thing because the way that it's organized is the unique super chatters per month. And I have no guarantee that, in fact, there probably are some of the same people super chatting from month to month. But this is the total unique individuals that were super chatting over the course, you know, like take the unique super chats in a month and then add all that together for the total number of unique individuals giving super chats each month. And then I split that up by affiliation. So this is like the company they're with and then their English name. And what this allows us to see is who was getting the most people giving them super chats during this time period. So if I do this, this function orders that for decreasing. So we have the person who had the most people, unique individuals, loosely defined, giving super chats at the top, and the one with the least at the bottom. And so this is our first one. Let's see what we have here. So during this, the time period when this data was being collected, dear God, this is what happens. See? This is what happens. I tried to make it bigger so that we could all see what was going on at the same time, the font size, and that's just making everything gross. You can't see it all at once, unfortunately. So the person who was getting the most super chats during this time period was Kiryu Coco from Hololive. The most people were giving Kiryu Coco. See, like I told you, this is an older data set. I know Coco has graduated a few years ago. Lamy was getting the second most. Subaru was getting the third most. Most of them, like the first however many, are from Hololive, and then the person getting the most super chat, or the most people giving them super chats from something other than Hololive was Kuzuha from Nijisanji. Oh, look, Keisan's on here too. So this data set must include a very specific period of time, huh? Yeah, but I thought it would be fun for us to go together. So if there's go through this together. So if there's anything that you'd like us to like analyze, anything you'd like us to look at. Oh, look, here's Pikami. Aw. We can absolutely go through that together. I think it seems like a lot of fun. So if there's anything that you're interested in looking at, my next interest in particular is I want to see. Actually, let's look at maybe we could look at which agency was getting them like the most money from super chats in this data set. Do we want to do that? And of course, I'm open to any suggestions or anything you might want to look at. Right now, I'm kind of doing descriptive stuff, but we can also do some hypothesis testing, you know? But first, let's see. Which agency was getting the most yen in super chats? So we can do that as aggregate. This sounds interesting. Yeah, I think so. Let me check our variable names again. Supa. What did I call this one? Supa.m. Here we go. Aggregate, and this would be, it was total SC by affiliation, right? It's all from 2101.15 onwards according to metadata. Yeah. I think it only goes through like 22, like sometime in 2022 at the latest. You know what? What we could do is, when was the most recent data in this data set? And what we can do is we can order supa period. No, wait, not supa. That's not the one we want. We want super.m. And then we can, actually, we could probably just do something a lot simpler than this. We can do max super.m period. Yeah, the most recent data is from August 2022. So yeah, it looks like January 2021 to August 2022. I'd be quite interested in seeing how it scales with more members. Like, is there a point where the audience gets seemingly saturated? We could do that, couldn't we? We could do accounts. So, okay, I'm gonna put this, all right, so let's do a regression. Seeing if agency predicts super chat volume when controlling for number of members. Yeah, let's do that one next. Haha. All right, so first let's do this. Super.m, and then do we want to do this as the mean or the sum? So like the total of all the super chats? Or do we want this the average super chats that they get in a given month? I think total. So let's go sum. So first, Maybe I should sort this, actually. Let's sort this. We can call this, total yen. And then, total yen, order, total yen, total SC, decreasing equals true, comma. Oh, right, I forgot to say, can't work if I don't do that. Okay, so, it looks like we have... Okay, so Hololive and Niji-Sanji were absolutely getting the most. Oh my gosh, Hololive during this time period, that is over 2 billion yen. So I want to try out, I found a package that apparently can convert between currency. So I want to try and see if we can do that. Let's try it. I'm going to create a section here in my code. Currency convert, or loading packages. I'll call it loading packages. And I'm going to have to install this package. So I might actually hide RStudio just for a second, just in case it shows any inconvenient file paths. All packages. And apparently the package that can do this is called price_r. All right. And then... All right. So, let's try and figure this out together. We're going to try and figure out... Okay. So, oh! So this allows us to do it based on the date of the transaction as well. I wonder if that's like... Oh, that's interesting. Because, you know, of course, exchange rates vary. Exchange rates vary, so it makes sense that the date of the transaction would make sense. And we could do that. Could we also check what periods or month were highest grossing for each agency in terms of super chats? Absolutely. Absolutely. Do we want to do that first? Let's do that first before we try and find out which months were highest grossing. Okay, so all that we need to do is we take this, and then we aggregate it by that plus period. Oh, oops. Oh, did I mute? I don't know, I didn't mute. I should be audible. My sources are telling me that I'm audible. Am I not audible? Strange. Okay, let's see. All right. This is not organized well. I should make this into a table maybe, but that would be a huge table. Okay, so should we graph this actually? But then there's so many different groups that trying to think of the best way to organize this data. My brain is thinking in pivot tables. And I don't know how I could duplicate this. Duplicate the pivot table. I wonder if I could do that though. Like, would an ordering thing work? Order total yen or 2. It was you. Glad to have you back. Huh. I wonder how far we can go with order. So let's see. The highest grossing thing was Hololive in December of 2021. Then January 21. Niji-Sanji's highest grossing month was August of 2022. When did Luxium debut? No, they were in 2021. Was it Noctix? No, Noctix was February 2022. What happened in Niji-Sanji in August of 2022? Like, it feels like something must have happened, right? Because, like, this is... Well, I guess it's not too... That feels pretty appreciably above their next highest one, right? I don't know. What happened? I'm trying to look. That was Noctix's half anniversary. They had a fair number of birthdays, but I imagine they always have a fair number of birthdays. Nothing in particularly exciting seems to have happened. They had Virtual Real debuts? I wonder why. There were two... I guess there was Oliver Evans's 3D reveal and Lane Patterson's. Yeah, I wonder. I don't know why. I don't know why. Google mentioned a tournament, but the page isn't loading. Yeah, what was it? The Niji-Sanji Koshien 2022. That could be. That could be. Maybe that's it. Maybe that's why. Maybe that's why they were doing so well. Let me see. I wonder if I can turn this into something nicer, like table. Let me see. I have my script reference here, so I can just refer to it if I need it. It's always good to have a script reference. Okay, table function. So what, like, that, or total yen, total super chat, no, not that, table total yen 2. Also, this is gonna be fun, because there's a risk I'm going to use my number pad, and unfortunately, all of my toggles are bound to my number pad, so you might start to see my toggles come off and on depending on how shenanigan-y I get, which is dangerous. Okay, so let's do affiliation, total yen 2, period. Is this going to do what I want? No. Let's see. See, my secret is that... My secret is that I haven't actually done much coding in R in a while now. It's not usually something that's required of me when I'm teaching, so I'm rusty. This is me practicing. Let's do some Googling and figure out if there's a nicer way to organize tables in R. Because I would like to do the thing like a nested table. I think that would be very nice. I'm not talking about R Markdown. Ah, this might be nice. No, I'm not feeling it. I'm being lazy. I'm a horrible, lazy human being. Isn't that right? We're just lazy people. Well, I don't want to speak for you. I'm a lazy person. What I'm gonna do now, I want to figure out if I can get this price R package to convert us some things. So let's convert our currencies. Oh, this tutorial is using Plier, dplyr. That's interesting. I'm not actually great at dplyr. It's kind of embarrassing. Okay. Total yen 2, or total yen. And then total super chat. This is what we want to convert. So, let's see. Convert currency. Total yen, total super chat. Sale date. I wonder if it'll... I wonder if it'll just automatically... Are those date things saved as a date? Let's check. Okay. So period is currently served as character. It's not currently saved as date. So we would have to convert it to date. Let's see. Can I remember how to do this? Let's see if this does what I want. Oh, that didn't do what I want. I'm gonna have to do some gross stuff to do this. So maybe I just put this on hold for a minute. It would be nice. I mean, I guess we could enter today as the current date, right? Why don't we just enter today as the current date? Right? We could do that. We could find out like what that would currently be from yen, right? We don't, it's fine. So what we're gonna do is sys.date, which should give us the current date and time. And that will allow us to figure out the current exchange rate between yen and then whatever we want to convert it to. From equals JPY to equals, what do we want to convert this into first? Like for me, I'm tempted to do USD because like I want to, that's the currency that I use, right? Oh, did I not? Is that? See, this is the struggle of coding, isn't it? Our convert currency. Oh, is it convert currencies? It lied to me. Oh. Oh, that's exciting. This is a different one. Okay. So that's that. And then this becomes US or yen, JPY. I mean, USD is still the global reserve for some reason. I mean, what? Okay, so local currency, I want to convert it into USD. USD. And then date transaction. At least you're reading documentation. Of course I'm reading documentation. Why would I not read documentation? Let's try this. Is that gonna... Okay, exchange, host, access key. Oh, I need an API for this. I'm too lazy. Okay, we can just do this manually, right? I can just... Well, so what's the current exchange rate? Exchange rate US or yen to USD. It is currently... So 1 yen is worth... Actually, let's do this the other way around. USD to yen. So 142.38 yen is equal to $1, which means that if I just stat total, or no wait, total yen, oh, and then I delete all my code. So let's do it here. Okay, so I can take my total yen, and then I want to show total yen, and I'm going to add a new column called USD, and then I'm going to take total yen, total SC, and then divide that by 142.38. This seems like the right way to do it, right? If it's $1 to 142.38 yen, then dividing yen by 142.38 should give me the US dollar rate, right? I'm not good at math. There's a dataset on Kaggle for USD to USD conversion against date. That's nice, actually. I'm lazy. So let's see. Let's just look at the first few rows, just so we don't get overwhelmed. Okay. See, look look at that. Look, we know what we're doing. So during this time period, 2021-03, HoloLive made $539,246.92, roughly, based on today's exchange rate. Sorry, JPY to USD. That is nice. That is nice. Honestly, I'm lazy. I don't feel like doing it right now. Is that bad? That should be how it converts. Oh, good, good. My math knowledge is... I'm not confident at all in my math knowledge, which I recognize is kind of funny. But, or maybe sad is the right way to put it. Okay, so now to see this next thing, I want to try what Astrologist was saying. I want to see if agency predicts super chat volume when controlling for the number of members. I want to try that. And the trick with this, of course, is it's going to be difficult to get the number of members from this data set, but we can get the number of unique channels listed in this data set per agency, which is what I think I want to do. So, channels per agency. And to do this, what we're going to do... Actually, I'm going to test this first before saving it into an object. I'm going to do, let's see, summary as factor, and then super.m affiliation. And that should give me the number of channels for each agency that are currently in here. So there's 156 for .lives, 411 for 774 Inc. How many are there for... Oh, no, wait, this isn't working. This isn't going to work. What I need is not from this data set, because this data set counts people multiple times. I need it from the original channel data set. And that will give me it. Okay, these numbers are making more sense. 207 with Niji Sanji. How many are in HoloLive? 92. Yeah, these numbers are making a lot more sense. Yeah, we gotta be careful how we deal with our data, you know. We gotta make sure that we know what we're doing with our data and that we know what our data represents. Okay, so this produces a vector. Let's call this, so now I've got to convert this into 2 columns, I think, is how I'm going to do it. So what I'm going to, let's see if I can, channels per agent, I'll call it CPA for short. All right, so save that into an object called CPA. And now let's try and convert this into 2 vectors. One we want, or 2 columns. One column we want to be the row, or the labels, right? So what if what if I just data frame CPA, what does that, or I typed it wrong. The biggest enemy of coding is typos. Oh, does that do exactly what I want it to? That might. Now, I'm doing bad coding practices. When you create a new object, you shouldn't overwrite the old object, but I am being a very bad coder. Do as I say, not as I do. Okay. I want to check something. Okay, so those are the row names. So that's not currently counting it as a, that's not currently storing it as if it's data. So what I'm going to do is I'm going to do row names and then call that affiliation. So now... this should, there we go. That's what I want it to look like. Perfect, perfect. Now what we can do is we can merge this into the super chat database, right? We can merge this into the super chat database. So currently that is super.m and we're gonna merge it. So I have code for merging data sets here because we have to make sure that we have all of this stuff in the same data set or we won't be able to analyze it. We need what? We need the name of the agency, we need the number of channels with that agency, and then super chat volume. So that's what we need. So we need to make sure all of those are in the same data set, and currently that is not what we have. So we're gonna merge super.m with CPA by affiliation. And I'm going to test this first just to see what this does, to make sure it's going to do what we want it to do. Okay. So all of these should be the same number because they're all the same. They should all be the same agency, so they should have the same age number. Oh, no, wait, I don't want super. I don't want to merge it with super M. I want to merge it with, what am I merging it with? No, I do want to merge it with super M, right? And this should say the affiliation here. Right? Yeah, all these are .live, so they should all be the same. Let's look at tail. Let's try tail. So all of these are 4, so they should all also be from the same, and yeah, they're all from UniCreate. So I think this is doing what I want it to. I'm gonna call this regdat because I think we're gonna be doing a regression. Okay, so let's see if the number of talents, or at least the number of channels that could potentially receive super chats for an agency predicts the number of super chats. Oh man, this is gonna get gross, isn't it? Because this is a multi-level model, because we have multiple months. Oh, I hate that. Oh, I hate that. I don't want to do a multi-level model. I mean, I can treat it as repeated measures, but I don't really care what month it is. I guess we can do time as a covariate. We can probably do time as a covariate is what I'm thinking. Okay. So let's try this. All right. So we're predicting. What do we want to predict? Total SC, I think. I think we're doing total SC as our prediction. So the total, wait, was this the amount that they made? Or the amount of super chats they received? Because that's different. What did you say? How it scales for more members. Do we want to look at whether the number of members in an agency predicts how much you get in super chats or how many super chats you get? Maybe I should start a poll. What should our DV be? And it can be either number of super chats, or it can be amount of money from super chats. What do y'all want to see? And I guess we can do both eventually. Once we get one code working, it's super easy to do the other one, but which is our priority? Do we have one? Because I'm fine with either. In the meantime, I'm going to start setting up this regression. So we have whatever our DV is going to be. And then predictors. First, I think we should have affiliation times, what did we call it? CPA plus period. And then we have a repeated measures variable in here. So what we've got to do is, let me check. Okay. That's what I'm doing. Okay. But we have a repeated measures variable in here, and I need to make sure I have that. They both sound very interesting, especially if they don't line up. I agree, because like it could be that one agency's getting a lot of super chats, but they're not making a lot of money because all their super chats are small, whereas another agency's getting very few super chats, but they're huge super chats, right? So I think that's an interesting thing to look at. I think it should be ID, yeah, plus error ID over source. Okay. Plus error. And for ID, let's use, I guess affiliation is the level of analysis that we're working with. No, wait. channel ID? No. Maybe... And then... If this works, I'm gonna be really impressed. Oh, right. I didn't put the dependent variable in. Okay, we're gonna start with the amount of money from super chats, so... yeah, that sounds right. Okay, so I need a regression with a within subjects variable. It's been a while since I did this. Actually, I don't want that to be there. Okay. You can tell I'm out of practice. That's what this is for. So how do we deal with this? Oh, right. Duh. Okay. Give me a minute. We got this. We can do this yet. One. So we're doing a random intercept for date. No, wait, do a lot of random... I'd like... Okay, I think what we're gonna do is... random intercept and a random slope, as well as a random grouping factor. So grouping factor is gonna be... God, we are doing a multi-level model, aren't we? Oh, I hate this. I am so full of hatred for multi-level models. No offense to multi-level models. They're super handy. Which I don't think I have this package installed, so I'm gonna have to hide this again. See, like, is there an easier way to do this? Absolutely. But I want to do it right. Until I rage quit and inevitably give up on doing it right. But, like, for now, I'm gonna try and do this the right way instead of the easy way. You know? Does that make sense? It makes sense in my head. Okay. So, we need to do LMER. That's the package that we're gonna do. We're gonna organize this, our dependent variables, that, by affiliation times CPA. And then our random slope will be, we think that the slope might differ by... Well, first of all, we've got, I'm gonna have affiliation. I'm gonna allow affiliation to have random intercepts, and then I'm gonna allow random slope by... What happens if I just do this? Okay. All right. Actually, this is a horrible idea because we have so many affiliations here. So it might actually make more sense because we have shit power, right? Like we have horrible power here. So what I think we need to do is we're just going to remove affiliation as a thing, and we're going to allow different, so we're going to allow different places to have different intercepts. So different places, different organizations are going to have different intercepts. So controlling for, what am I doing? I'm going to allow period to have different intercepts. I'm gonna eat my arm. I'm gonna eat my arm. I think that's what I'm gonna do. The easiest way to do this, of course, would be to see if the number of talents is related to the amount of super chats you get. You know what? Actually, So first of all, there does seem to be something going on here. I don't have the brain for a mixed model right now. I'm sorry. I'm betraying you. I'm betraying all of you by not doing a multi-level model right now. That would be the correct way to do it. I do not have the brain to do it right now. I'm not going to do it right now. I'm sorry. I'm failing you. But okay. If agency predicts super chat volume when controlling for the number of members, please do not eat the VTuber models. Yeah. Okay, so here's the deal. Here's the deal. The problem here, what we're gonna do, first things first, I don't want to deal with time period. So we're just gonna create a data set that deals with the overall amount of money that they have made over time. Okay, and I think we actually already made that. That was this one, right? Total yen? Yeah, total yen. We already have this data set. What we're going to do is we are going to merge total yen with CPA, and that will give us a data set that only includes the affiliation, the time period. I don't want the time period, though. What I want is I just want to merge this. So I'm not taking into account the time period because I feel like that's making things unnecessarily complicated. That's what's giving me the headache here. So what we're going to do, we are going to take this data. I am going to aggregate that data for total SC by affiliation and CPA. And is that doing... Oh. Oh. Wow. Okay, here we go. So here we go. No, I don't want mean, I want sum. That's what I want. Okay. So this is the total amount of super chats, or the total amount of yen earned in super chats by the organization. And here's the number of channels for that organization. That is what I want. Okay. Okay. Now we're cooking with gas. And we don't need to worry about all that grossness. This is what we need. Okay. So we want our total super chat by CPA. That's all we need. So this isn't even really a regression. I'm just doing a correlation here. And I'm going to do an LM. Okay. So first of all, there is a positive relationship between the number of talents at an agency and the total super chats that that agency receives. Let's just do this in terms of a correlation. So that is total SC. Let's see. Let's see if I can do the correlation function by memory, because if I can, I deserve a treat. Okay, right, there is a positive correlation here. This p-value is significant. It's in scientific notation. The more people were at an agency, so the more channels an agency has, the more that they're making in super chats. Of course, part of the problem here, though, is that the biggest so-called agency here is independent VTubers, which is not necessarily super useful. And then also we have Twitch independence here. So I think let's try this again and see if this relationship between the number of talents and the amount of yen that they're getting differs by agency. I would like to do that. And to do this, we're going to have to narrow down the agencies that we want to include. So I'm thinking HoloLive makes sense. Niji Sanji makes sense. Are there any other... Do we want VShojo in there? Like, what agencies do we want to include? Let's try and keep it down to like 5 agencies max. Just for the sake of my sanity. The secret independent agency runs the genre. It's so true. This relationship varies by agency. And so we've got to pick our agencies. I definitely want to include Hololive and Niji Sanji. I think VShoujo makes sense to include as well. I'm thinking of like the biggest agencies that I can think of in the in the English VTubing space. But I'm not super tapped in. Oh, Idol Corp. Why not Idol? What else? Is there any other, like, VTuber agency that you really want to look at in here? You think would be super interesting? In the meantime, I'm just gonna create a vector of the agencies that we want to include. Hololive. VShoujo. And then I wanted to include Idol Corp too. We gotta include the organization that has size Evil Twin. Good Twin? Evil Twin? I don't know. Voice Twin. I guess we could include Kizuna Ai Inc., but that's like, you know, the one talent with the 3 things. Let's see. Phase Connect, maybe? I feel like I've heard a lot about Phase Connect. Okay, so there's the list of agencies. And if y'all come up with any agencies that you want to hear more, like, test more. I don't really watch agency VTubers, so don't know. That's fair. I honestly don't watch too many VTubers in general. This is my confession. So, I'm not super knowledgeable. Let's see. Okay, so what we're going to do is I'm going to redo this model, but I'm going to use a subset. Let's see if I remember the code. I don't have the code for subset memorized anymore. Okay. Subset, data, where... Nice! We did it. Is this the right code? It's been so long. Oh. Let's test this code first to make sure it's doing what I want to. Okay, it's doing what I want to. Double checking. Okay. All right. And then... Okay, and I think I'm missing a parenthesis. Let's move this like that, so it's a bit easier to see what we're doing all at once. Okay. I'm really happy that most code I'm running is working on the first try. Okay. Oh, right, I gotta do a summary. Okay. So first things first, it can't calculate p-fill. Something's horribly wrong. All right, so I've done something horrible. I was just bragging about how my code is working for the first time. And now it's not. It's working with Idol Core, and it's working with Niji Sanji on their own. It's probably treating, it's treating Hololive as the reference group right now. Let's see, what does this look like, actually? What does this look like? Oh, it's because I have too few data points. I fear no man, but as a lawyer, these numbers scare me. Hey, Bushi, how you doing? Yeah, no, I'm screwing up because I don't have enough data points. That's my problem. That's my problem. I'm a fool. That's my problem. I'm doing something where there is no variance. I only have one observation each for each of these things, so there's no variance. That is the issue. That's the issue. This was a fool's errand in the first place. You know what's better? Let's just test. Okay, so we know, first things first, what have we learned? We know that agencies with more channels get more money in super chats. Which makes sense. Let's check out the average, no, and let's, actually, you know what? Let's do this as a regression, but what we're gonna do, I want to do this same thing, but I want to control for the number of super chats. Doing good, preparing for my oral arguments tomorrow. It sounds like I'm a madman, emphatically reciting the law behind warrantless searches and falling in love with the Fourth Amendment. Nice. I believe in you. You have my full support. I'm great. I have great confidence in you. Okay. Okay. All right. So what did I want? Merge. Ah. Okay. So what I want is this, but I also want, what's this? I want to control for the number. So total super chat. Okay, so that's my problem. That's my problem. Oh, thank you for the hearts. Are you trying to support me in my struggle? In my eternal battle with code? It's much appreciated. Your Honor, the government argues that they didn't execute a warrantless search, but if this VTuber said they did, I'm pretty sure you know who's right. Oh no! Oh no! Is this what I need? That's not what I need. What I need is this. And then total super chat. And then I aggregate total. I aggregate. What are the names in here? Okay. I want unique super chatters. That's what or total. I want unique super chatters. Or no, I want super chats. That's what I want. Okay. Super chats by affiliation super.m sum. Okay. Okay. And so what I'm going to do is total SC. And let's see if this does what I want. Oh. No, wait. That's not what I want to do. Okay, what I'm going to do. We're figuring this out. Okay. We got this. Don't worry. Don't worry, everyone. This is real coding. Okay, so we want to merge regdat with total SC by affiliation, which should give us what we need. Okay, so we have the total number of super chats. We have the total, okay. And then what we're gonna do, or no, wait. Is this what I want? Okay, this is what I want. This is what I want. So what we can do, never code like this. This is a horrible way to code. Do as I say, not as I do. Okay. All right. So what we have here is we have a significant main effect of the number of channels at an agency. The more channels there are at an agency. Oh, this is interesting. Let's graph this. So first off, the relationship between the total number of channels, so we're predicting the total amount of yen in superchats. The relationship between the amount of yen in superchats and the number of channels you have is a positive one. But this is showing a negative estimate. Let's graph this. I think that we should graph this. I think that graphing this model will solve all of my problems. So, what we're going to do is, first, because we're graphing two continuous variables, we have two options here. We could create a 3D plot, which I know Sai has talked about in the past as a horrible abomination that shouldn't exist, but I kind of want to do it. So we're gonna create a 3D graph. Is the relationship between number of channels and super chat earnings moderated by number of super chats? All right. Okay. So what we're gonna do is we're gonna create a 3D graph, and Sai will judge me forever, but Sai doesn't have to know. I hope Sai's not here. So I know Sai lurks. Okay, so we're gonna have to install a new package in RStudio for this, and it's called RSA Tools. And then I'm gonna load that, and then what we're gonna do is we are gonna plot. Someone saying it's a horrible idea is the exact reason why you should do it. Absolutely. Absolutely. How did I do this before? I think first I had to get a model through RSA. RSA. Tools. Okay. Because we're doing response surface analysis, which is the way that I know how to do this. So, to do a simple RSA, we need to first do this. Okay. Wait, no. We need to do an RSA. We need to do a response surface analysis. So is this it? RSA model. Okay. Okay. Yes. All right, let's try. Let's try it. It's been so long since I've done this. Someone's saying it's a, oh no, I already read that. Okay. Equals total SC by CPA times super chats. Data equals regdat3. Does this do what I need? No, it doesn't. You're learning? Legendary art. I would never use this as an art tutorial. Yeah, let's not do that. I changed my mind. Let's just plot this normally. So the first thing that we need to do is... Okay, we're not doing violin plots today. This is a safe for work chat. Okay. We're going to do some effect plotting, I think. So... I think that's the name of the package that I need. Okay. All right, let's see. This is not good. This is like trying to learn English from a gacha game forum. This is not a good way to learn R. This is the horrible way to learn R. I am doing horrible things. Okay. What we're gonna do is model, and then hi Timmy, welcome to the chat. We're doing crimes against humanity. How do I usually do this? It's been so long since I plotted a continuous by continuous interaction that my brain is just like, what I've got to do is I have to, it's like, yeah, it's the thing. No, do I want to do, is this it? I think, oh my gosh, I'm a genius. Okay, I found my code. I found my code. I found my code. I found the code that I need for this. Everyone, false alarm, I'm still a genius. Okay, so this is, first, let's do, okay. So this is our first variable. For dat, all of our dat is regdat3. That's the name of our data set. I can't wait to find out what we have learned, because I still don't know what we have learned, other than everything was significant. Okay, CPA, and CPA. Okay, so that's above and below for variable. No, wait, let's do superchats. I changed my mind. So what we're doing right now is, because we have two continuous variables, it's easiest to graph when you only have one continuous variable. So we need to make the other continuous variable categorical. So what I'm doing is I'm going to say we're looking at the number of channels for an agency, predicting the total amount of money they got based on people who are who are getting a lot of super chats and people who are not getting very many super chats. I'm taking the number of super chats they got and plotting this at one standard deviation above the mean, agencies that got a lot, and one standard deviation below the mean, agencies that got not a lot of super chats. That's what I'm doing here. So our interaction was the number of channels per agency times super chats. Our model is called model. The levels for super chats is this. Okay, here we go. Here we go. Oh, it looks like this is going to get a little weird because it's extrapolating some stuff a bit. And then, you know what? I think what we need... Summary at CPA, or not that. This is riveting stuff. Did I spell that wrong? Oh, regdat3. Okay, let's try that. Because this is not doing what it should be right now. Okay, so I think what we need to do is so we're going to do something weird. We're going to... Oh, wait. No, that's not what I want to do. What am I doing? It's been so long. And then CPA equals sequence from the lowest amount of super chat, or the lowest number of channels per agency is 2, and the highest number is 470, and we're going to do this sequence by, say, 20? Maybe? So this should create... Sorry for the sirens. That should create something roughly right. Okay. This is looking nicer. That's more what I want to see. But it is weird. I think this is probably because it's a skewed distribution. Like, let's look at... Let's look at the histogram here. Yeah, this is a super skewed distribution. So most places are getting super chats that add up to, like, you know, like, not a whole lot. And then there's very, very few places that are getting, like, a lot of super chats. So that's the problem here. So this graph is going to look real weird. But we will persevere, okay? Are you ready to persevere? Are we ready to persevere? I'm ready to persevere. Okay, where did I have this? I don't want bar graph. I want continuous by continuous. Where's my continuous by continuous interaction code? Here we go. Okay. I've got to convert that to a data frame so that I can actually deal with it for the graphing. Okay. This is going to look so gross, everyone. Are you ready? Are you ready for how gross this is going to look? Because it's going to look so gross. Okay. Maybe I should plot it at the mean and then one standard. Let's see what this looks like, because it's going to look weird. It's not going to make sense, because it's extrapolating data that is below zero money in super chats, which it shouldn't be doing, but it's doing that because the distribution's so skewed. Most agencies are not getting a lot of money from super chats. Some agencies are getting crazy amount of money from super chats. So it's being weird because this is a skewed distribution. So our x-axis is the number of channels per agency. Our y-axis is the total amount of money they're getting in super chats. And we're grouping this by the number of super chats people are getting. You know what? Maybe it would make sense to do it the other way around. We can try that later. So I'm gonna comment this out. We don't need this right now. The factor is gonna be super chat. Size equals 2. Okay. Da, 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 da. Channels per agency. Our y-axis is super chats in yen. Super chat earning in yen. Let's see what this gets us. No? Oh, total. Oh, I'm a fool. There we go. That should, what? Oh my gosh, everyone. It's because I was trying to do error bars, but you know what? Screw error bars. Error bars are for nerds. Okay, so can I show you this better? I'm gonna move the chat. Chat can go back up here. I can shrink. Okay, so here's what we've got. Actually, I'm gonna adjust the legend position. I want it to be maybe... Okay, here's what we've got. Oh my god. What is happening? No, we're doing this the other way around. It might not make as much sense in my head, but we're doing this the other way around. This is a mess. I hope no one who knows what I'm doing is watching me. I like to think I look like one of those hackers, you know, in movies when I'm writing code. But I get the sense that I just look like a disaster. Okay. And then I want this in a sequence from, let's say summary, reg, dat 3. Trying to figure out, like, good breaks for the So the minimum number of super chats that any agency got, or the minimum number of super chats that any agency got was 7. The maximum was over 2 million. And we're gonna break this down by, say, 10,000? Does that seem fair? Does that seem reasonable? Let's see what that looks like. Maybe 100,000 makes more sense. I'm gonna bite. I'm gonna start biting. I hate skewed distributions. Every problem in my life currently is skewed distribution. So what we're gonna do is we're just gonna do this, okay? We're gonna do that because that makes more sense. And then what we're gonna do is 0 standard deviations from the mean and 1 above the mean. Oh my god. I think what we need to do is scream forever. I think that would fix me. I think screaming forever would fix me. I think that would be great. Right? Right? I think that would be great. I think screaming forever is the solution I need for life, the universe, and everything. I think that would be incredible. 1, error bars are for nerds. Oh my gosh, you are so right, Fi. I think you summarized it up. But actually, in this one, I am going to add in error bars. You know what? Error bars are for nerds, but I am a nerd. You know? So let's make freaking do it. We're going to do error bars. Okay. So the weird thing about this. So just to remind you what we're graphing this regression. This regression was looking to see if there was an interaction between the number of channels for an agency, the number of channels an agency has, like YouTube channels, the number of YouTube and Twitch channels, the number of super chats that agency has received over the course of this 2-year period, and if those interact. We found a significant effect of channels per agency. It looks like, based on this graph, agencies with more channels, that's the blue line, we're earning more money than agencies with fewer channels. So having more VTubers in an agency got them more money. We're also finding a significant effect of the number of super chats they got, predicting earning more money. So that also makes sense. So first of all, having more VTubers in your agency predicted earning more money. Second of all, getting more super chats in general predicted earning more money. What is going on with the x-axis here? Something horrible is happening with the x-axis. We are going to make that make more sense. So, and then they're interacting, and I need to change the x-axis because this is looking ridiculous. Okay, so summary reg dat 3, and the first thing we need is that. And this will determine the bounds of our y-axis. The minimum, I hate you scientific notation. I know there's a way to get rid of it, but I don't know what that is. R get rid of scientific notation. Okay, there's code for this. Okay. Does this do it? Does this do what I need? Perfect. Okay, so the minimum on our y-axis is going to be 7,657 yen, because that's the minimum amount that an agency earned through super chats during this time period. And our maximum is going to be 2,800,000,000 yen. Oh my god, that's a lot of money. Okay. Our x-axis needs to be this, but for the number of super chat received, where the minimum is 7 and the maximum is over 2 million. Let's try this again. Okay. Why are you doing? It's just not displaying the x-axis. It's like, screw you. No x-axis for you. It's probably because the number of super chats for like Hololive and Niji Sanji is so much bigger. In fact, those two are outliers and are probably affecting the results. So maybe we should try running the regression without them, because they might well be driving this interaction. But right now, the interaction looks like, for agencies with more VTubers, so agencies that have a lot of VTubers but aren't getting many super chats, aren't making a lot of money. But when you have a lot of VTubers and are getting a lot of super chats, you're making more money, which makes sense. Then for the agencies that don't have a lot of VTubers and aren't getting a lot of super chats, they're actually making more money than the agencies that do have a lot of VTubers but aren't making a lot of super chats. But when they're getting a lot of super chats but they don't have as many VTubers, they're not making as much money. And honestly, I think this makes sense. But let's see what the pattern looks like if we exclude Hololive and Niji Sanji from it. Okay. So we're going to subset this data. And then affiliation is not in, and then it's not equal to Hololive, or affiliation is not equal to Niji Sanji. First of all, I want to make sure that works. Does this spit out an error at me? Yeah, it does. Perfect. I'm a genius. Okay, that did what I wanted to. Okay. All right, so if we exclude Hololive and Niji Sanji, this is still popping out significant. But I want to see what happens if I graph it without those two, because those two are clear outliers. Wait, did I do something wrong? Did something screw up? Oh yeah, of course, of course. Because what I need... Oh my god, okay, everybody, I'm gonna be so smart. Are you ready? Are you ready for me to be a genius? Okay, so what we gotta do is we're gonna take this code, we're gonna copy it, we're gonna create a new section, blah, and then we're going to paste it. And what we're going to do first is we are going to create regdat4, which is a subset of regdat3, where affiliation is not equal to Hololive, or affiliation is not equal to Niji Sanji. Okay? And then what we're going to do is I'm just going to Control F regdat3 and replace it with regdat4. And then we're going to redo this whole freaking thing. No. Why do you hate me? Why does everyone in this godforsaken life hate me? Oh, I know why. Don't even worry about it. I know what our problem is. It's fine. So, what we're gonna do is all we have to do is this. All we have to do is... Wait. Wait. Okay. It's still in there! Why is it still in there? No! You're wrong! It's not... It's not... ugly, gross. I'm not actually saying these, I'm not saying Hololive and Nijisanji are ugly, gross. That's not what I'm saying. I'm just venting my frustrations. I'm venting my frustrations. Okay? Okay. Wait, how do I... Only keep not in R. Only keep values not in list. That's what we want. Okay. So what we want... Oh! Wait. Is this? Yeah! Okay, we did it. Okay. Now we can be geniuses. No. Okay, and then what I want to do is summary regdat for super chats. Okay, now, okay, so super chats is our x-axis. So now it's 650,000, and then thank you for the hearts. We're getting there, everyone. Don't worry. No, we're gonna get it. Everyone, we are so smart. We are the geniuses of our time. And we are gonna achieve what people never thought was possible. We are gonna make this graph. Wait, okay, so this is 670 million. Oh my god. Okay, we did it. Look at those error bars, by the way. Those are some teeny tiny baby error bars. Oh wait, we should remove the because this includes independence, right? So what we need to do is we need to remove the indie VTubers. How did they call it? What did they label those as? Everyone, we can do it. Okay. We're almost there, everyone. We're gonna do it. We're gonna do it. We are in the zone. We are hydrated. Cool, that's a cool way. Yeah, isn't it? I like how you can't even see the error bars at all. But it's okay. Oh, oops. I have done horrible things. Okay. Oh. Okay, okay. Oh my god, okay. We did it. Okay. Here we go. No, wait. Shoot. It's okay, everyone. It's okay, everyone. We are so good at this. We are so smart. Okay. So, super chats. Super chats. All right, so now it's 180,000. And then total SC is, dear God. Okay, 170 million. Okay. All right, here's our graph. We're finally making sense. So, significant effect of the number of channels per agency. First of all, agencies with more VTubers, so excluding Hololive and Nijisanji and excluding indie VTubers, agencies with more VTubers made more money. That's a main effect. Agencies with more VTubers made more money. Second main effect, there's a main effect of the number of super chats. Agencies that got more super chats also made more money. I'm gonna adjust the graph, there we go. Third, the interaction. Agencies with a lot of VTubers also got more money from the super chats they got. So like holding super chats constant, agencies with more VTubers were also getting more valuable super chats. Agencies with fewer VTubers, even if they were getting the same number of super chats, those super chats were of lower value. Now, what we can do is we can also test this. I guess what we could do, probably not worth it. But yeah, that seems to be what we're seeing here. What we're seeing here is that having more VTubers in your agency will earn you more money. Getting more super chats on its own for your agency will also get you more money. But getting more super chats is more effective when you also have a lot of VTubers. That's what this is showing us. Of course, we can't establish causation. This is all correlational, but you know. It's just what that's what we're seeing. That's what we're seeing. Oh my god, we did it. What do we want to look at next now that that ordeal is over? Now that that ordeal is over, what should we look at? Let's remind ourselves of the variables that we have. Okay, so we have the channel ID, which is not super useful. We have the name of the channel, we have the English name of the channel, we have the group the channel is affiliated with, we have the number of subscriptions the channel has, we have the number of videos the channel has published, we have their profile photo, we have the time period that this was from in months, we have the number of super chats, we have the unique amount of people giving super chats in a given month, we have the total number of super chats they received, or super chats is the total amount they got through super chats. Average super chat is the average amount that they got through super chats. Total message length is the total number of words in the super chat, average message, and most frequent color for super chats. So actually what this would predict is if I'm interpreting this data correctly, we should see that agencies with more VTubers also get higher average super chats than agencies with less VTubers. So let's test for that correlation. Do agencies with more VTubers get higher value super chats? Because that's what this is implying. That's what this data is kind of implying in this interaction. And we have the data to test that, right? So let's do core.test. Our first variable would be super chats, which is the total amount that they're making by super chat. Our second variable is average, no wait, it's CPA, because that's the number of channels per agency. So wait, do I have that in, where am I? Who are we? I don't. Everyone, we need to defeat the enemy. I'm going to scream. It's okay. This is how we can win. All we need to do, I'm saying this before thinking about it. I'm going to name this because I think that's an appropriate name. And this time we are... Dang it. Dang it. What we need to do is we need to bite off our legs. This will solve all of our problems. I think that will solve all of our problems. Okay, so what we're gonna do is we're gonna do this. And then we're gonna bite off our legs. Instead of total super chats, what we're gonna do is we are gonna take average super chat we're doing that by affiliation. And this time we're going to do it. Okay. So that gives us a data set called which looks like this. So that tells us this. The average, I'm so glad I didn't miss this. Hi, Xeno Time. Welcome to the Scream Pit, where we just scream. We just scream forever and ever and ever, and we slowly lose our sanity, but we keep persisting, which is not good for our sanity. Hey, Flibby McGiggles, I'm new here. By the way, are you Squidward in disguise? Hey, welcome, welcome, welcome. Happy to have you. I am not Squidward in disguise, unfortunately. I do not have a musical bone in my body. Does Squidward have bones? Does Squidward have bones? Do squids have bones? Was Squidward a squid or an octopus? He must have been a squid, right? Do squids have bones? Squid. They are soft bodies but have small internal skeleton made of chitin. Or chitin. How do you pronounce that? I don't know. I do not have a musical bone in my body, and therefore I'm not Squidward in disguise. I cannot play any scientist and losing sanity. Name a more iconic. He's an octopus? Squidward an octopus? We need to count the number of legs he has. Squidward has 4 legs. Octopi have 8 legs. How many legs? Chitin. Okay. Do squids? Because octopi have 8 legs. Barring few exceptions, Wikipedia says, barring few exceptions, octopi have 8 arms and no tentacles, while squid and cuttlefish have 8 arms, or 2 legs and 6 arms and 2 tentacles. Squidward is nothing. I mean... Squidward is none of these things. No, wait, Squidward has the 4 legs and the 2 arms. What species is Squidward? Octopi have 8 arms, yes. Hello, Maury. How are you doing? Welcome to my slow descent into whatever the hell this is. He first, despite having squid in his name and having only 6 tentacles, Squidward is an anthropomorphic octopus. Maybe he had an amputation. That's sad. Okay, so the real question is, do octopi have bones? Nabby Zoo says no. Okay, so octopi don't have bones. So Squidward also doesn't have any musical bones in his body, but he has a musical heart. At least one. Don't octopi have 2 hearts? Am I making that up? Octopi heart. Octopi have 3 hearts. So Squidward has at least 1 musical heart in his body, and I have no musical organs whatsoever. So I am not Squidward in disguise. That was a very long answer to a very simple question. What's an androtation? What is an androtation? Don't they have 9 brains? I don't know. How many brains does an... This is getting totally off track. Octopi. The mind of an octopus. I guess I'm willing to bet the answer depends on how many brains you have. Isn't there like a marine biologist VTuber? Can we ask them? Can we ask them? I mean, amputation. Oh, amputation is the removing of a body part. It's usually it can be a medical procedure, or it can be something that happens by accident, but it's like having a limb amputated would mean that your limb is separated from your body. Either for medical reasons or just other reasons. Mm-hmm. Does it count as an amputation when you get your hair cut? Does it count as an amputation? What is the definition of amputation? The loss or removal of a body part, such as a finger, toe, hand, foot, or arm or leg. Does losing a fingernail count as an amputation? Can you get, is a fingernail... Okay. An amputation is a traumatic loss. It's not really a body part in the same way. That's what you say. That's what you say. An amputation... Amputations... Okay, so here's OSHA. Let's see what OSHA says. An amputation, for OSHA purposes, is the traumatic loss of a limb or other external body part. Include a part, such as a limb or appendage, that has been severed, cut off, amputated, fingertip amputations with or without bone loss, medical amputations, degloving. Amputations do not include avulsions, enucleations, degloving, scalping, severed ears, or chipped or broken teeth. What is an avulsion? Small piece of bone gets pulled away from the main part of the bone. Please let Mylan let me cut my fingernails in peace. No. Does a haircut count as an amputation? Not an amputation, but a haircut. Do barbers do amputations? What is considered an amputation? I kind of want to, like, I need Blue Sky to put up polls so I can ask Blue Sky if a haircut counts as an amputation. Imagine a random person clicks on the stream and they see you doing this. That's what you did. You're a random person who clicked on the stream and now you're seeing me do this. No, I guess to be fair, you are part of the cause of this problem. It's true, barbers were pre-surgeons. Barbers are amputating my hair. This makes perfect sense to me. What were we doing? Barbers did do proper amputations back in the day. It's true. It's true. Oh my gosh. So an amputation does not require loss of bone, according to OSHA. Kitty, you should replace the number 3 in your code with N octopus hearts and 9 with N octopus brains. I could do that. I could. I feel like that would get confusing real fast, though. I feel like that has the potential to break a lot of things, but it is tempting. Maybe instead of naming this dataset, I can name it Octopus Brain. Okay, so this new dataset is called Octopus Brain. And now I'm adding this stream to my watch later. Awesome, you can watch my full descent into madness at 2 times speed. It's perfect. Okay, and then we need to merge in the one that includes CPAs, which, what did I call that? I just called it CPA. Okay, so, octopus heart, merge, I'm gonna merge CPA and octopus brain, and then, what's merge code again? I don't have the code for merging datasets memorized yet. By equals, okay. Okay, so our new dataset is called Octopus Art. And our goal was to figure out if VTuber agencies with more talents get higher value super chats on average. I'm looking forward to you mixing up Octopus Brain and Octopus Heart in half an hour and going insane. It's entirely possible I won't need to use these data sets again after this. The Octopus Heart has all the data I need. I don't need Octopus Brain anymore. We can throw away the brain. Apparently, octopi have spare brains, so they don't need all of them. Okay, core.test. CPA, average, SC. And then data equals Octopus Heart. Oh, did I type that wrong? Oh, it's because I have a data set and a column. That's my problem. Okay. All right. Oh, that's interesting. So there is no significant relationship between the number of... That's weird. That's real weird. Wait. So what would happen then if because I thought that was, I thought that explained this interaction here. Like if it's that larger agencies are getting higher value super chats, that would explain this interaction. But it's not. That isn't a relationship. Wait, we get to do a mediation. Oh my God, okay. So first we need to get this all in the same data set. That's our first goal. So we have to merge again. What should we call this one? Maybe this one is, okay, merge. We want to merge octopus cart with reg dat 4 by affiliation, which means okay. So that one. Okay, so this should have, it has the agency, it has the number of talents in agency, it has the average number of, the average amount in a given super chat, the total number of super chats, or the total amount from super chats, and the total number of super chats. So theoretically, I get the whole thing with Squidward and amputation on recording, by the way, so I can post it, so it's so funny. I'm glad. I'm glad. I hope that it is as hilarious as it sounds. So I think theoretically I shouldn't be doing this. No, I should. Okay, no, wait. So my goal is I need to make sure, first off, my goal is I need to make sure, in case there are any CS people in chat, this is exactly how scientists code with exactly as many unintelligible I'm normally much better than this at coding. I am much messier coding live than I am coding like properly. This is not how I would normally code. I promise you. I promise you that my code is normally so much nicer than this. Like I think there are cases, there's some stuff on like, yeah, so if you go to my isekai video, I think like the video on like isekai stats, if you go to that, I believe I actually have some of my I have my R script in there. Let me open that. Let me open my R script for isekai stats. No, wait. No, wait. To show you what my R script like looks like normally. Okay, so this is what my R script normally looks like. It is so look at this beautiful labeling. It shows you this. It says here's my section for descriptives. Here's where I cleaned the data. Here's how I figured this out. Look at how clean this is. I even have different sections so I can like here's where I did this. Here's where I did this. Look at that. Look, my data is so nice. It's so clean. It's so well commented when I'm actually trying. This is just from some definition Googling, hair is a body part, so if an amputation is the removal of some body part, then surely a haircut is an intentional partial amputation. Thank you. Thank you, Astral Anthropos. All right, well, I believe you normally write better, but it's still an R, so get wrecked. Fake language. You want to fight? You want to fight me? I will fight you right now. Okay, so wait. So if I want to do this as a mediation, I need to make sure that my mediator I'm hungry. What are we doing? Whatever. I'm gonna do this badly. I'm just gonna do the mediation. Do I not have mediation code in here? Do I not have mediation code in my... Oh, no, because I'm looking the wrong thing. Okay. Do we want to do a mediation, or do we love ourselves? I don't think I love myself enough, so we're going to do a mediation model. Okay, so if you're wondering what a mediation is, a mediation allows us to test whether a relationship between two variables is driven, like, so let's say in this case, the question I'm asking is, does the relationship between the number of VTubers at an agency and the total amount of money they make, is that driven by the average super chat? Which means, like, is it that agencies with more VTubers get higher value super chats? Is the reason that agencies with more VTubers make more money is because they are making more money per super chat, which is kind of what this interaction here might be suggesting. So I gotta install some packages again, so I'm gonna hide R again. Sorry. I don't want you to see my file paths. They're a mess. Installing packages. Okay, there we go. All right, so the data set that we're using is called It's this one. Okay. Okay. So first, wouldn't this be correlated rather than driven by? Since yeah, we can't say driven by, but mediation at least allows us to say if this isn't in the middle of these two variables, you know, like, is this thing in the middle, it's complicated. Like, it's still correlational data, but we can draw some conclusions about potential causation from it. Like, of course, we can't, like, it's better for establishing causation than just a plain correlation, but it's still correlational. We can't, like, truly establish causation, but it can help rule out alternative explanations. It can say this is what comes in the middle. And, like, there's various, it's complicated. It's a little weird, but yeah, I can't say this is driven by blah. I guess I could say this relationship is mediated by blah, which would be the sort of technically way of putting it. But wait, I don't know. It's oh, I'm glad it makes sense, because it wasn't making sense when I was saying it. Okay, so we want I think that, was it total S super? No, it's total SC by CPA. So, okay, that's the fit on the mediator. So this should be, the mediator is average SC. So there's our first one. So that's the path, that's the first path. This is the number of agencies per VTuber, is that related to the average amount in a super chat? The next, what we've got to do is your independent variable. So this is our mediator. This is our independent variable. No, wait, this is the mediator. Average SC. This is our independent variable. And this is our dependent variable, which was that total SC. We test our assumptions. We are not meeting some assumptions. Oh, wait, did this not run? Oh, I put the name of the wrong data set there. So we're violating some of the assumptions of this type of test, which is not great. That means these results are not going to be very reliable. So that's unfortunate. We can't place much stock in this. We really shouldn't place much stock in this anyway, because for a lot of reasons. But yeah, we probably shouldn't anyway. All right. Treatment is CPA.x, and then the mediator is average SC. Okay. Summary. All right. Proportion mediated. Yeah, okay, there's no mediation going on here. So this would be the proportion of the relationship between the number of VTubers in an agency. So this is looking at how much of the relationship between the number of VTubers in an agency and the amount of money they're making is explained away by the average amount of money per super chat. And this confidence interval includes 0, indicating that this interaction does not exist because agencies with more VTubers are getting higher value super chats. That is not why this interaction exists. Good job, team. Oh, man. Oh, boy. Yeah, proportion mediated, not significant at all. So there is a significant total effect, which makes sense. We've already established that the number of VTubers in an agency is related to its total amount, like total money that they earn through super chats. And this is not at all mediated. The amount of money per super chat is not a factor in here. So what else do we want to do? Or I guess we've been going for 2 hours. I could probably end the stream soon, but I feel like I haven't actually accomplished all that much on this stream. Yeah, it is kind of interesting. Like, honestly, it makes sense that... Because there's another variable here, right? It makes sense that agencies with more VTubers are making more money because, 1, they have more VTubers, which means they have like a wider audience, and 2, it makes sense that companies that are making more money in the first place would feel comfortable taking more VTubers under their wing. So it makes sense that companies with more VTubers are making more money, and also companies that are making more money have more VTubers. Like those, it's kind of like a reciprocal relationship in there. But this interaction was kind of implying that there's a third thing going on here, where companies with more VTubers are making more money than companies with less VTubers at the same number of super chats, which is why I wanted to test that mediation, because this interaction kind of implies that, like, one explanation for why that would be the case is that companies with more VTubers are getting their same super chat is worth more money. That would be one explanation for this interaction here, but that doesn't appear to be the case. So, yeah. And that's including the error bars. Like, you can see the error bars. It makes sense that agencies that are getting fewer super... We don't have as many small agencies getting a lot of super chats. That's what this bigger error bar means. Like, 0 standard deviations is actually the average sized agency. Like, the typical agency is not actually making as much money from the same number of super chats as a large agency. But our estimate here, our error bar for the amount of money that a smaller agency is making at that amount of super chats is bigger, because smaller agencies just aren't getting as many super chats as bigger agencies. Like, we could test that, right? We could look at the relationship between the number of super chats and the size of the agency, right? So I could do like CPA.x, super chats, data equals, oh, shut up. I can code live. I'm so good at coding live, everybody. How many A's did I put in this data set name? Everything that I've done today was a mistake. This is why fun variable names are a mistake. Fun variable names is fun, but use them at your own peril, right? Right? Okay. So yeah, there is a relationship here. Companies with more VTubers are getting more super chats, which makes sense, right? I mean, it makes sense. If you've got more VTubers, you're getting more super chats. And also, if you're getting more super chats, you feel more comfortable getting, you know, like, hiring more VTubers. It makes sense. It makes sense. So in that way, it's kind of boring. What were we talking about? Octopi having bones? What are we doing? I don't know what we're doing anymore. My sanity has been dripping out of my ears this entire time, just slowly. What could we look at? We could start ranking VTubers. Like, if we want to do descriptive data, we can say, like, which VTuber got the most super chats, or, like, I don't know. That's a thing we could do. Or which month were people sending the most super chats? That could be fun. What we could do is... I don't know what I'm doing anymore, everyone. I confess, I don't know what I'm doing. No one knows what we're doing. Everything is strange. Haircuts are amputations. It's fine. What was I doing? Right, which time period? Okay. So which time period had the most... No, we already did that, except we split it up by affiliation, which is not... I want to do that without splitting it up by affiliation, right? Because this was... We split it up by agency and affiliation, but I don't want to include that. This time, what I want to do is all I want is I want it split by month. I just want to know when VTubers were making the most money. That's all I want. So let's look at that. And let's do this by, like, let's do it by sum. Right? Oh. Test. I don't know. I'm just naming stuff now. And then let's do this. Test. Test. Okay. All right. The most money in this time period in the data set. December of 2021 was the most profitable month in terms of super chats for VTubers, earning... Let's convert. So this is 647,405,800 yen total earned by the VTubers in this data set in December of 2021, and that was the most profitable month for the VTubers in this data set in this time period, which I believe was January 2021 through August 2022. Christmas merch? Holiday merch? Presents? New Year's streams? Maybe? No, New Year's streams would be January, right? And January was not as profitable. Huh. I don't know. Any other burning questions that we can address? Any other burning questions? Anything that we want to learn? I'm going to check our variables again. So we've got the name of the VTuber, or the name of the channel. What is group, actually? What's group again? Oh, group is the... So this is the unit, and this is... Group is... We could do some fun things with that, potentially. What is it? So, like, if I just, like... If I just say, I only want the rows where affiliation follow live. Oh, wait, what? Oh, right. Oh. I got this. Don't worry about it. I can do code live. There we go. Okay. So these are only the HoloLive ones. So let's see what that means for group. What is group here? Okay, so it tells you the generation. So we can see, like, we can look at the generations of Hololive and see. We can see, like, which generation got the most super chats, which generation, like, this and this and that. Right? And most frequent currency is actually also kind of interesting. What if we, table. So, first of all, what I'm gonna do is, let's call this Hololive. And I'm gonna do, okay. I'm gonna create a data set that is only our Hololive people. Oh, wait. Oh, I keep doing this wrong. There we go. Okay, so this is only Hololive people. Let's make a table and Hololive group and Hololive most frequent currency. Okay, so it looks like our general, you know, like the plain generations, they are most commonly getting Japanese yen. We have, is this, I don't know what one is, or TWD, I'm not sure. And we have one USD super chat for the first generation in this time period. But the Japanese groups are largely getting donations in yen. The English groups are largely getting donations. What do they need? Hope? This is called, no wait, it's not Hope. What is it called again? What's the new name for Holo Council plus Iris? It's, what do they call it now? New Taiwan dollar, that would make sense, yeah. Hololive EN Gen 2's name is, I should know this. I should really know this. Right? Promise! Promise! That's the name. Okay. Holo Promise is mostly getting money in US dollars and some in Korean won. Interesting. Myth is only getting super chats in English dollars. Gamers, again. Oh, what's this? Holostar's second generation. Interesting. They are getting super chats from a lot of different places. And Indonesia is getting USD and Japanese at a fairly, that's weird. So Indonesia, the Indonesia Hololive, the Indonesia branch is actually only getting a minority of super chats in, I'm guessing IDR is the Indonesian currency, right? Yeah. Yeah. Okay, so most super chats for like Holo EN are in USD. Most super chats for Holo JP are in yen. But for some reason, Hololive Indonesia is getting a fair amount in USD, a fair amount in yen, and relatively little in Indonesia's currency. That's interesting. That's weird. It's kind of neat though. Yeah, yeah. Weird. That's kind of neat. I wonder why. I wonder why. What else can we look at? We can see which gens had the most subscription counts as well. That's also something we could do. I don't know. Y'all got any ideas? Here's the variables we've got. We haven't done anything with message length either. Or color. Maybe, rather than most frequent currency, we can go with most frequent color of super chats. Oh, I want to do this as a... Oh, I did the code wrong. It's fine. So it looks like the group that is getting... Do we have red on here? Is there no red? Red super? Red super? Red super? Ah. Yeah, red is an option. That's weird. I'm pretty out of ideas that I don't expect to be unrelated. That's fair. That's weird. For some reason, there are no red, like, akasupas in the HoloLive section of the dataset. Who has the akasupas, then? Would have expected... Which super most frequent color? Red. Which agencies are the red supas going to in this data set? Indies, we've got Prism Project official channel. We've got somebody from Niji Sanji. Got some Niji Sanjis in here. Kizuna Ai. That's so strange. There's no akasupas at all going to HoloLive in this data set. Did I do something wrong? What if we try the original, like... Super chat stats. So this is the original data set. That's so strange. No akasupas for HoloLive during this period, in this data set anyway. That seems unlikely. That seems unlikely. Weird. Weird. No idea what that's about. It's too bad that this is by the month and not by the super chat, because like I'm kind of curious if super chats that are higher value have longer messages on average. I feel like that would be a fun thing to look at, but it looks like I don't have that data, unfortunately. Maybe subscription count? I also kind of want to see if I mean, it makes sense that subscription count would be related to the number of super chats. And of course it is. I wonder if average subscription count is related to message length. The reason I'm thinking this is, like, do you think that, like, the more subscribers a VTuber has, I feel like the harder it is for their viewers to get very parasocial about it. So I'm kind of, like, But I mean, that's not the only thing that would affect the length of a message that you send to a VTuber, how parasocial you are. But I'm kind of thinking, like, the more distant you feel from a VTuber, the shorter the message you might send. And the closer you feel to a VTuber, the longer the message you might send. And therefore, if we use their total audience size as a measure of distance, like perceived distance, which of course is not a perfect thing, but like, I'm kind of curious. I'm expecting a negative correlation here. Maybe not a strong one, but... Oh, it's a positive correlation. More popular VTubers got longer messages on average. Interesting. Or, well, VTubers with more subscribers got longer messages, which is kind of the opposite of what I was predicting. It's not like a strong correlation, but it is a significant correlation. It's interesting. Yeah, weird. But if you wanted to be seen in a busy chat, you might yap in the super chats. That is also true. That is also very true. That is an alternative explanation. Makes me wonder if this is moderated by anything, but I don't know. Unfortunately, I'm sorry if you can hear the clacking. I'm gonna save this. I think we're kind of running out of steam. I think my sanity has reached its peak. Well, I'm regaining my sanity, actually. I feel like I'm regaining my sanity because my code is actually working a lot quicker than it was during that real, like, down period. And I feel like that means that I should probably stop, because the more sane I get, the more boring this will be, I feel. Where we're no longer talking about whether octopi have bones or how many hearts they have or anything. Yeah. All right, I think that's good. I think we did good. It's been 2 hours and 20 minutes. I think it's fine to call the stream here. Oh my gosh. Well, thank you all for joining me for whatever the heck that was. I love analyzing data. I know this was kind of chaotic, but I'm not trying to be weird, but for some reason you are so underrated and entertaining that I've been watching for the past hour or so. Oh, thank you so much. That means a lot. Thank you, thank you. It's all right. I've returned to send Mylan on tangents. Oh no. It's okay. I love going on tangents. Oh, never mind. Oh, ope. You said ope. You said ope. It's okay. I say ope too. Ope is a very valuable word. You're sending me on a tangent. This is bad. It was a really fun stream. Thank you for coming. I really, really, really enjoy analyzing data. I don't think that this was the best data set for it, but I still had a lot of fun, and I hope that all of you had fun as well. And I also just had fun talking about really weird stuff. So thank you all so much for dropping in. I hope that we can analyze data together another time. I will have to find another fun data set to work with. VTuber data is kind of, I feel like it's a little too real. Like there was a lot going on during this time period, and there's always a lot going on. So I'd like to find just like a weird, fun data set, like, I don't know, UFO abductions. I know data sets on that exist, or like in the past, just for kicks and giggles, I've like analyzed data sets of like the McDonald's menu or whatever. I think I would like to do more data analysis streams and maybe make them a bit less chaotic. Try and actually display good analysis and code practices as opposed to whatever the heck all of this is. It actually looks like it kind of makes sense for most of it, oddly enough. If you're not looking too hard, it looks like it's actually semi-organized code. Interesting work and relaxing to listen to. I'm glad. It's funny to me that this was relaxing because I was just like all over the place for all of this. So I'm glad that it was at least somewhat relaxing. Oh, I do actually want to, in the future, I think, so my next stream, I'm working on a video, by the way. It's still in the scripting phase, but I think my next video is probably going to be, I'm going to be doing a tier list of APA style rules. Because some APA-style rules are really weird, some of them are not so weird, some of them are very useful, some of them make no freaking sense to me, so I thought it would be, like, both fun and educational to do a tier list of I'm ranking all these weird APA-style rules. So that's the next video that I'm planning. And hopefully it'll be fun for people who've used APA style before, and it'll introduce people who are not so familiar with APA style to some of the more obscure rules that might trip them up when they're writing an APA paper. Yeah, I'm excited about it. I think it's going to be fun. And I have strong opinions about some of this stuff, so I think it'll be funny. And then the next stream I'm probably going to do, I've been thinking of doing another art stream. I'm going to an event this summer, and I'm not going to say what event, I'm not going to say where, I'm not going to say when this event is, but I'm thinking I might print out some VTheorem stickers and leave them on a table where people tend to leave flyers at this event. So if anyone's if anyone likes VTheorem and happens to be at this event, they will be able to grab some VTheorem stickers just there. But of course that means I need to draw the stickers. Now, this does mean I'm going to have to I'm going to be printing the stickers from my home printers. They might not be very good quality, but I think that my next stream will be drawing some VTheorem stickers. I think, probably. And I don't know when that will be. Maybe next week, we'll see. We'll see. There's a lot going on, so. But yeah, that's my plans for the future. And actually, now sounds like a great idea to eat. Time to eat. All right, everyone, have a great day. Thank you all so much for coming in and witnessing whatever the heck that was. And I will see you next time, whenever that happens to be. Yeah. Thanks, everyone, and take care. Have a great day. Bye.